CORBA is an acronym that stands for Common Object Request Broker Architecture. It provides interoperability among distributed objects, regardless of whether they're remote or local, regardless of whether they're written in different languages or in different locations of the network.
I think that the reason why CORBA is worth knowing is that it is like a siren song, because you look at it and you're like, maybe I should go towards this. And the answer is always no. I think at this point, this type of model doesn't seem to work.
Hi, this is Will.
And this is Sri.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. How's it going, Sri?
Pretty good. How about you?
Doing pretty well. It's been a long week, but I've got my drink, and we're here to just sit back, kick back, and drink some drinks. What have you got this week?
I've got this good gold thread elderberry defense. It says it's going to boost immunity and carry on. So I guess maybe you need this more than me, but what do you have on your end?
Well, I have something completely opposite. I have the bubble tea brown sugar drink. I mean, this is the first, I don't know, it looks like a coffee looking brand, but it's brown sugar flavor with tapioca pearls. The first time I've seen it in a can, honestly. Yeah, I'm still waiting for a drink maker that makes canned pho. I think that would be as a warm drink. But unfortunately, in the US, there are no warm drink vending machines like there are in Japan. But I think definitely I would want to chug some pho once in a while.
Wow. Okay. I hope you make that happen and we see it on this podcast one day.
So if any of you out there listening are in the food industry, just pitch it. Just pitch it. Like, green light it and send it over. Yeah.
All right. So what are we talking about this week, Will?
So this week is another retro episode. Yay, jazz hands. So this is an episode in which we talk about a technology from the past as it was trying to look to the future, but we have the benefit of hindsight, and we're looking at it from the future, effectively. So this week we're going to be talking about a technology that was all the rage in the late 90s called CORBA. So CORBA is an acronym that stands for Common Object Request Broker Architecture, and what it does is it provides interoperability among distributed objects. It enables the exchange of information independent of hardware, platforms, programming languages, and operating systems to distribute objects to communicate with one another, regardless of whether they're remote or local, regardless of whether they're written in different languages or in different locations of the network. And so that's a mouthful, but did you get all that?
Well, yeah, I kind of. So it seems like it's super ambitious in that it's trying to make services and programs talk to each other, regardless of what language they're written in. They could be talking to each other over a network, and it's supposed to magically solve probably some of the hardest problems in computer science.
Yeah, I forgot what the quip was or where the quote's from, but somebody wrote that you probably shouldn't get to use multiple computers until you learn to use one first. And I mean, that's in reference to how in distributed computing, there's a lot of hard problems that come up that don't really exist when you're just programming a single computer. And so CORBA was an attempt to do distributed computing, because at the end of the 90s, we could see that there was the rise of the web, and like computers were getting faster and faster, and the networks existed. And so it's natural to think, well, we've already had the computer revolution, and we nearly have a computer on every desktop in the world, and that was Microsoft's mission. And now that networks are coming on, it's not a far stretch to say, how do we get all these computers to work together in a global computer? And so that's where they were at now. And so do you remember what the 90s were like the late 90s?
Sort of. I mean, I think it was definitely the age of the desktop, and the internet was relatively new, or not the internet, but specifically the web was still relatively new. But I think network connectivity in the enterprise was catching on and probably getting prevalent to the point where people were looking to write network services. Yeah.
And so it was a little bit of a different world back then. Like, people feared Microsoft, and it was like the only tech giant in town. Like the FANG acronym, or what's it now, Manga? it was just M, right?
Yeah.
Back then it was just M. And before that it was like IBM. Like everybody feared IBM like back in the 70s or so, 60s and 70s, but like their power waned, and in the 90s and especially late 90s it was Microsoft. And that's because they had the dominant operating system in the world, which is Windows 95, and if you wanted to do anything in computing, you had to go through them. And so if you thought Apple's App Store was like shit show, I mean, like Microsoft, you would like deploy stuff on their platform and then they would just copy your application and then put it on as a default in their operating system. They would do stuff like that. Or they say, let's collaborate, and then they just take your code or copy it or something like that. And so that was
embrace, extend, extinguish is
right.
is the phrase. Yeah.
Right, exactly. And so like if you talk to programmers beyond a certain age, they still like bristle at Microsoft because that scar runs deep. And so beyond that, to kind of set the stage for what the computing world was like at that point. Like for me, I was in college or so, and so that's from what I remember. I wasn't working quite yet, but yeah, like Microsoft was dominant. There was the internet, but it was mostly dial-up. You get some like cable, but like in order to have a fast connection, you're like at a university or something like that. But most people were on dial-up. A lot of people were still on AOL, but slowly coming onto the web.
Yeah, I think also another interesting thing at that point was that open source did not exist as we know it today. I think that
right.
Apache web server was probably one of the first open source that was used for running your server, for actually being able to run a service or a business on top of it. And so at this time, a lot of computing, especially in the enterprise, was done by buying vendor-specific software or basically buying giant servers like IBM WebSphere and things like this that were sort of giant monoliths on which you kind of ran all your business logic.
Yeah, I mean, startups of that age raised VC money in order to pay vendors for stuff. Like people would pay Oracle gobs and gobs of money just for a database that they can run their like web apps on. Like that's kind of the world that we were in. And I think Java was pretty big. They were kind of the first programming language to push its popularity through marketing dollars, and they did a pretty good job of it. And so that was kind of the world as it existed in the late 90s or so. So if you can imagine that. So yeah. It's within this context that we have CORBA. And so did you look into a little bit about how it worked or what they were trying to achieve with that?
Well, so I know that one intriguing aspect of CORBA is the fact that they model things using this distributed objects metaphor. And so it seems like you can imagine that your computers on your network are exposing these objects, which are similar to any kind of objects in traditional object-oriented programming in a la Java and C++ style object-oriented programming, where they expose certain methods that you can call. And CORBA basically says that you can access any object that's on your network and then make method calls on it, and the computer on the other side will execute them and return a result as though all of this was happening on your own machine.
Yeah, and so that is a good mention into the atmosphere at the time, which was like object-oriented programming was the thing. Like Java is one of the things that helped push it. And as we mentioned in our small talk episode from before, like the object-oriented programming that we ended up with in Java and C++ and other like popular languages in the late 90s were a far cry from the intention with small talk and stuff. So if objects were the technology du jour, why not just extend it across the network in distributed computing? And so I think that was the thought. And as we know in hindsight, that ended up to be a pretty bad idea for a variety of reasons that we'll get to.
Yeah, but it seems like a good idea. It's very appealing to say that you're going to architect your service such that each server has a separation of concerns. It handles a certain set of objects. Maybe you have a search service or search server that exposes an object that, allows you to search over a bunch of documents or something. You have some other database service that does some other thing. You have a storage service that exposes a different storage type object, and you just talk over a network. And so it's an appealing concept at first glance.
Yeah, definitely. I think because one of the things that OOP embodies is abstraction through encapsulation and data hiding. And so when people were practicing abstraction, they're like, I know, we'll make remote procedure calls look like local procedure calls, and we'll just abstract over all this network business, and we'll make them the same. And it turns out that was one of the core things that made it a really bad idea. But we didn't know that at the time.
Yeah, that makes sense. Yeah, so, I mean, I think it might also just be worth talking briefly about how all of these things are wired up. And so I think that
Yeah, definitely.
in like CORBA, you have these objects and they define an interface, and you sort of define that a priori using this like things called like IDLs, right? Interface definition languages, description languages.
Yeah.
Yeah, and then that's how the computers on both sides of the connection know what methods are available on the network, and then basically these IDL files get parsed into some stub functions, basically libraries that when you call them on your local machine, then they dispatch that call out to the network, and then they wait for a response, and the other side, when it sends a response, you parse it and you carry on with your computation.
Yeah, and so in the middle of all of this is something called an ORB, or a object request broker, and I guess they named it ORB to make it cute. And nowadays nobody names things with acronyms in technology unless you're working in the government, and so this is also a sign of the times. But the object request broker in the middle is the thing that orchestrates these IDL stubs and skeletons between the client server objects. So it's kind of the place where the IDLs and the interfaces are published, and it's where all the requests get routed through.
Interesting. Is the ORB like just a fancy name for like a network, or is it an actual server that is routing these requests around?
My impression is that it's an actual server that's running these things, routing these things around, because it, in all of the facts and the diagrams I saw, it has its own box. So, and it's not like a super flat box. So, I mean, even like message buses usually are like a flat box, and so, but there's usually a server there. So that's my impression.
Interesting. Okay, so that already seems like a bit of a red flag, in that if you have a middleman server that is brokering all of your communication between all the services on your network.
And broker by the name, like it's in the name. There's a broker there, right? So presumably it's otherwise it would have been called a network.
Yeah. Okay. So interesting. That seems dangerous, but yeah, you don't see that kind of architecture anymore. But for the most part, services like microservices these days do direct like point-to-point connectivity.
Yeah. Because I guess the reason why is it's a single point of failure. And so if the request broker goes down, your entire system goes down. And I guess Chaos Monkey at Netflix doesn't have that much of a job. They just hammer on the same server to see if it goes down, I guess, right? So
yeah.
But yeah, that's why nowadays, and probably, I don't know what the scale of enterprise systems were back then, but I would guess that our web services and distributed systems are probably much bigger now than they used to be.
Yeah. So you're saying back then things were not web scale.
Yeah. Web scale. Their web scale might be an order of magnitude smaller than our web scale. Yeah. And so that's where it's at. And so the other thing also is that you can have more than one of these object request brokers, and they would talk to each other over some sort of like IIOP protocol. I don't even know what that is, but I guess if you want to distribute the load, that's the way that would happen.
Interesting. It also seems like it could be appealing if we're talking about fancy enterprise deployments where you could have brokers between companies, or like one company and a partner company talking to each other, and they're able to kind of access each other's services. That seems like something that people might want. I
mean, interoperability is like a huge thing in enterprise, and like even nowadays it's such a pain in the ass that they hire consultants, and it's like a multi-month if not multi-year effort to do integrations. Like
yeah that makes sense. So I mean, if you think about the stage, what the world was like at that point, it seems like CORBA was trying to actually free some of these companies from vendor lock-in and having to just vertically scale their servers to handle all of the load, because it seems like the point of CORBA is that you will have kind of smaller servers that have separation of concerns, and you don't have to worry about what they're running, what language they're running, what platform they're using. And so it seems like a kind of way to kind of disintermediate some of these vendors and be able to have interoperability and maybe free up, some licensing dollars or something.
As an aside, like people talk about supporting multi-cloud deployments, and sometimes people are like, why would you want to do that? Like when's that ever going to happen? Well, if you're big enough to acquire new companies, that it's going to happen. Like you're not going to spend all this time like migrating people over. So yeah, same problems, but a different solution, same problem, I guess. Yeah.
Yeah, totally. So, I mean, and we do have this issue of also wanting to communicate between different languages, even within the same company, because many companies, either through acquisitions or through policy, say, the teams are enabled to use whatever language suits their domain or whatever language they are able to hire for or they have expertise in. And so if you want all of these services within a company to be able to talk to each other, you do need some way to interoperate between these things. And we use things like remote procedure calls still today, even though they're not necessarily talking over a request broker. You have libraries like Thrift and gRPC today, which people use.
Yeah, and so all of this is just to say that the problem that CORBA was trying to solve wasn't a bad problem to solve. At the very least, they identified an important problem. It's just that they ended up not doing a very good job solving that problem for a variety of reasons that we'll get to, I guess, right now. Like the influence on computing today. Like, would you say that CORBA has influenced a lot of the systems that we have today?
I think that it has influenced them as an anti-pattern. If you look at the mentions of CORBA on Hacker News especially, people are grumbling nonstop, like, CORBA, like it was so horrible. My project was slowed down because we had to deal with these CORBA services, et cetera, et cetera. So I think that if anything, it serves as what not to do.
Yeah, I think it left a bad taste in a lot of people's mouths for a variety of reasons.
Yeah, I think it makes sense because we didn't really have a lot of experience with networked computing at that time.
Yeah.
And so, especially in the enterprise, just like a decade before, CORBA came out, so like early 90s, it was probably a big feat for a company to kind of digitize and have one service that is running entirely on computers. And so now with CORBA, like, you're able to have multiple services talk to each other, but that was probably the first time that people were doing this.
Yeah, I mean, like, there were still CRT monitors on every desktop then, and like early 90s, I think were the Pentiums, like the 586s, like that's how far back we're going. And just having networks of computers were only at really, I guess, large companies, large universities, and we're only starting to figure this sort of stuff out, like you said. And also, I think one of the main immediate things that gave ex-developers of CORBA this visceral reaction to CORBA was that it was just so terribly complex to implement. I'm not sure exactly why I didn't dig into it that far, but it seemed like it was just a lot of APIs were complex, inconsistent, or downright arcane, and I guess it forces developers to take care of a lot of detail. And so I think that was the main thing that really hampered the implementation, but then there were like external forces in addition that helped its death go quickly. And one of the reasons why we're talking about it today is that when it first came out, it was like the new hotness, like people wanting to get on this thing, but because there were all these like showstoppers, like it ended up fading away.
Yeah. I think, it was also coming at a time where big enterprise computing projects were written in languages like Java, for the most part, if they were not part of the Microsoft ecosystem. Things were talking over XML. Things had all these kinds of schemas associated with them. Actually,
XML came a little bit later.
Okay.
XML is own sort of thing, but yeah, like like the CORBA API and stuff. Like it was just it's effectively like remote procedure calls with objects, and so there was no XML going over the pipes for CORBA or anything like that.
Okay, interesting. Yeah, so I guess, but it was very much like embedded in enterprise computing as we know it, which is, as it is today, still very complex, probably full of boilerplate, and people were probably just making a lot of money being kind of architecture astronauts in these very complex systems.
Mm-hmm. Yeah, I remember as a college student in high school, I wanted to do some Windows programming, and I just thought I was a terrible programmer because I'm like, this stuff is so complex. But like now I look back, I'm like, yeah, the guys at Microsoft back then, they just really like to over-engineer things. So perhaps with a good reason, I don't know, but yeah.
So yeah, like what made things so terrible? So it was complex and difficult to work with. Were there like any other sort of failure patterns?
Yeah, I think one of the things with CORBA itself was that there was a standards body and a consortium that helped establish what these APIs and interfaces were like. And these were terrible in the sense that it was designed by committee. And so it sounds good on paper that you would want to get representatives from different companies and different vendors to come in and vote what the APIs and the different proposals are. But what ends up happening is that you get people that suggested these specs with no reference implementation. That was not required at all. And so people would recommend stuff that just did not work or were overly complex. And so that was one failure. And another is that, like, to have a concrete and focused vision of the API, you didn't have like a benevolent dictator at the standards body, and so, which was called OMG. I forgot what it stands for. Object Management Group, I think. And so there was nobody around to say no. Like you want somebody there to say no to stuff, but like, because there wasn't, and everybody just kind of voted because they're like, as long as their own like needs were met, they don't care about anything else. So there was no like focused vision for the API, and so that's where you get like terrible design by committee that way.
Interesting. So it's actually the opposite of what we have today with standards, especially when it comes to web browsers, where there is no standard and the behavior is just whatever the reference implementation does.
Yeah, right.
I guess, if you do it in either extreme, it ends up being bad.
Yeah, I mean, I guess I'm amazed that it all works, I guess, is the summary. And so I think in terms of the technology itself, there's that. Also, there was no security model. They sent this data over the pipes in the clear. Like, there was no encryption at all. And so they tried to slap it on later, but I mean, like, when you're working with a standards body with that sort of attitude, like that would also be tough. But I think there were also like other external things that were happening at once, because I mean, technology moved really fast, I guess, back then and now as well. It's just that when you look at it, CORBA was only really popular through the span of, I want to say, like 5 or 6 years maybe. And so I guess that's a lifetime in technology. And so at the time, there was the rise of the web, and just as CORBA was getting popular, and they didn't address like the web at all in their specification. And so two, like the EJB Enterprise Java Beans in Java provided a component model to use, and that got entrenched by the time that they were able to address that. There was no versioning of any sort for like your object models. Once you like deploy it, if you have like another thing that is like, how do you deal with versioning of different objects? And so that points to one of the issues with providing objects as a service, because it's too low level detail. You can almost say it's an implementation detail of a particular service. Like, if things get changed out, you don't actually want to have to put that out there for people to use directly. And so, because then you would have to deal with this sort of like versioning problem in a very granular sense.
Yeah.
Right.
And that's okay if you're working in the context of a single process, because in most programming languages, you don't update your code on the fly. You can't update the definition of a class on the fly such that now you need to worry about all the callers within that process having to switch to the new version. But this is something that can happen trivially when you have two computers, because you can update one and not update the other, and now you have this version drift.
Right. Yeah. I mean, it's a problem for event sourcing architectures, and I guess that goes back to Kafka, where like it has a message bus where like different versions of different messages might live on for however long you're keeping messages around. So, yeah. It's interesting when we look at these retro stuff, we see similar patterns in the stuff we use today, and I can see how the graybeards get really jaded sometimes, like, new stuff, same stuff. And then just to kind of go through these other things quickly, like Microsoft never hopped on the train for CORBA, and they developed their own standard called DCOM, Distributed Component Model, and people were like, should we go with them? Should we not? But like Windows didn't win it out, even though they were like the biggest company in tech, because it was only for Windows. And then they decided to, in DCOM, they published SOAP, which I think a lot of people don't remember now, but basically it was a way to do APIs over XML. And then later on, like, JSON subsumed use with XML because it was too complicated. But yeah, and then in 2001, the bubble burst, and everybody's like, we don't have any money for any of this stuff. So there weren't a lot of people trying to spend money on CORBA. And so I think they were like, there was just a lot of different punches left and right, in addition to like they didn't have their house in order, that contributed to its fall.
Interesting. Yeah, I mean, I think it's hard to fault CORBA that much. Maybe it's easy for me to say because I didn't have to write any enterprise programs at that time and have to pull my hair out. But, like we had just said, this was a learning time for everyone. It seemed like kind of noble goals. And the thing is that, like you mentioned, I think everybody missed the rise of the web. We were talking in the Smalltalk episode about how Smalltalk was around the same time, actually, going around and trying to sell different versions of Smalltalk. There were vendors who were selling different versions of Smalltalk.
Yeah.
And they also missed this whole rise of the web. And I think that, this was probably happening around the same time where everybody just got blindsided and they were building for this idea of having, these big beefy servers and thick clients and things. And then the web came along and kind of flipped all of that around. And so none of this ended up being necessary.
Yeah, actually, like Sun Microsystem, which was in charge of Java, they were trying to shift to a thin client where Java was the client for everything. But so for people that saw the web coming, even they missed it. Like Microsoft, eventually, Bill Gates was like, okay, he did his weekend retreat, thought about it, wrote a memo about how the web is a threat to Microsoft, and then they still missed the boat, right? And so I would think that it's easy to forget where people's minds were at that time, because even technologists saw the web as kind of this dinky thing that was not well designed. Even nowadays you can find quotes about how I think it was Alan Kay that was saying, TCP IP, now that is a great distributed system designed by people who knew what they were doing. When it comes to HTML, HTTP, amateurs, right? Amateurs. Yeah. But I mean, it's simple enough that people were able to adopt it. There's only a couple of verbs that you need to know, and you're able to pull information down from servers. And yeah, people didn't think about it as a way to deliver applications. And even if they understood that, they saw it and they're these applications suck, right? And it's only the new guys like Paul Graham at the time. I think he was just out of college, probably. I think he was working by then. And he's like, oh, we can deliver applications through the web, and it's got all these nice properties that we can iterate, and we can write in any language that we want because we control the server. But at the time, people looked at it and they're like, this thing sucks. It looks crappy. The page refreshes. It's not responsive. There's no way this is gonna replace desktops, right?
Yeah. It's interesting to think at that time, the idea that the web, and when we say the web, specifically HTTP and web browsers, the idea that the web would be able to deliver applications of any significance was completely new. Around that time, maybe late 90s or early 2000s, there were things like the first HTML webmail clients.
Yeah, Hotmail.
Yeah,
yes, exactly. I was an early user.
Do you still have the @hotmail.com?
No,
address?
I don't have it anymore. But I did because back then it was so hard to get an email account that webmail for a high school kid was oh, this is great. I have my own email address. And I remember they actually Hotmail actually posted a message saying it's down for the day because we have to move our servers because they physically drove their servers somewhere else back then. There was no cloud computing.
That's great. Yeah. So, the idea that you could deliver applications that way to a web browser, it was new. And if you look at kind of before the web started becoming an application delivery service, the way that network services worked was that they would have their own layer on top of TCP IP. And they would define some standard by which that service worked. So if you had email, you would have SMTP and things like that, and news groups and things had their own thing. And so I think CORBA was sort of falling along those lines, where they said that, well, on top of TCP, probably they wanted to build another service that was this kind of distributed objects layer, and then it turned out that everybody, maybe starting with SOAP and then going on with REST and kind of modern APIs, people were forget making our own specialized layer on top of TCP. We're just going to make our own layer within HTTP and sort of not mess around with having another layer on top of the OSI network stack.
Yeah. It seemed like for I don't know, for whatever reason, but like you said, everybody figured that, oh, okay, HTTP seems good enough. And I guess one of the things is worse is better. If it's easy to get, people will write implementations for it. And so I guess it was good enough that people were able to start using it and then bastardize REST to fit your like application needs.
Yeah.
So that, I mean, I don't fault that, I guess, but like people change REST to mean what it means for them so that they can get their work done. And so that's what we ended up with. But yeah, I can see that at the time of the mid 90s, like before the web really took off in the .com era, which is in the late 90s, like they wanted to take OOP, which has been really successful and marketed, and extend it to distributed computing. And so it didn't work because of all the fallacies of distributed computing also. Like beyond like kind of the economics of the time and the market, like have you heard of the 8 fallacies of distributed computing?
Sort of. I don't know them by heart, but I probably should.
Because nowadays like all web programmers are distributed programmers. We just don't know it.
Yeah.
Yeah, so these things are like, if you look on the web or the YouTubes, you would be able to find talks on the 8 fallacies of distributed computing, and along with them, funny anecdotes about what it is. And so we'll post some of those on the show notes, and you can check it out yourself. But just to run through them quickly, things like these are fallacies that you would have as a regular programmer of a single computer if you try to pretend that remote procedure calls are just like local procedure calls. And so these are things like the network is reliable, latency is 0, the bandwidth is infinite, the network is secure, the topology doesn't change, there's only one administrator for the network, transport cost is 0, and the network is homogeneous. Basically, like all these things contribute to the fact that you can't abstract over remote procedure calls to make them look like local method calls, because there's all these complexities and exceptions that'll happen if you try to treat it as such.
Yeah, and if you're familiar with databases at all, there's this thing called the CAP theorem, which kind of is a database view of these same fallacies, which is that there are 3 properties of a database. You can have sort of consistency of data across multiple instances of your database. You can have availability, and you can have partition tolerance, which means that if there is a network disconnectivity, your database remains responsive. And you can only have 2 of these 3. It's kind of one of those pick 2 of 3 things. And it also all kind of hinges on these 8 fallacies of distributed computing. Basically, if you have sort of a stateful service like a database, you cannot maintain like perfect consistency, availability, partition tolerance. One of those things has to give. And what is interesting to me, I don't know if there's a formal equivalence between these two, but if you have distributed objects and these objects encapsulate some state, and even if the object itself is not a stateful object, if you have this request and response pair between a client and server, that request and response connection is sort of stateful. You aren't able to maintain all of that perfectly in the face of a changing network, something gets disconnected, a server goes down, all of those things.
Yeah, one of the interesting things that I've read was connecting distributed computing to physics as it relates to space-time relativity, because in physics, where you're dealing with vast distances across the universe, and how even though the fastest thing is the speed of light, you still get these delays. And how do you get messages from one place to another with these delays? Like, these very issues are exactly the same sort of things that come up in distributed computing. And so our basic notions of time on single computers just go out the door when we have a distributed system. And like messages can appear out of order, even though you sent them in order. They can arrive from the future, they can arrive in the past if like the clocks on all your machines aren't synced correctly, and all this sort of stuff. And so yeah, I mean, like, that's what makes this sort of thing hard. Yeah, and so that, I think that's part of the reason why it's just so hard to abstract over it. And they're like, the systems that we ended up with today are such that we just try not to do that, I think, for those of us that learned the lesson. And so that speaks to like how Erlang and Elixir, like they're famously for a distributed system that was originally built for telecos, and they don't use RPC. They go with the actor model and say everything is message passing. There's no shared state. There's no shared namespace. If you want anything done, just send a message. And that's and they treat all method invocations. It's not really method invocation. It's like you pass a message to like another process, but they make explicit that the other process, whether it's on this machine or another machine, will always look like a remote invocation. Like there's no assumption that everything is local. And so they were very successful with that particular model for these distributed systems.
Yeah. And I think that message passing in general seems like a good way to get at building network services. And honestly, CORBA took the wrong version, the twisted version of OOP, which meant that you have objects that have methods on them. If you look at the definition of OOP that Smalltalk used, they also used message passing in that objects didn't necessarily have fixed interfaces. They would just respond to messages, and if you sent them the right message that they were expecting and they could handle, then they would send back a response. But you didn't have these rigid interfaces, and so in that sense, actually, you wouldn't have some of these problems with kind of tightly coupled client and server implementations, and then what do you do when you need to upgrade one or the other, because you don't have this rigid coupling. You just sort of send a message, and then if it can be handled, you'd get a response back using another message.
Yeah.
So obviously, CORBA, with its rigid interfaces and its single point of failure with brokers and things like that, didn't pan out. And I think that reading the comments on Hacker News, people really took those lessons in stride. They sort of kind of licked their wounds and came up with sort of better services or ways to structure services. And so now we live in a world where you have microservices that are talking to each other over REST, and so it's the same problem, but it's a different set of acronyms and a different set of jargon that is hopefully better. Do you feel like things have gotten?
I think in a way. I think in a way. Like one of the things that I recognize about REST architectures is that there's some sense of self-description in the protocols itself, because with an RPC, it could be anything. Like the interface could be anything. You have no idea unless you request the interface from the object broker and then have to figure out like exactly how do you interact with the service. With REST, you can use the basic HTTP verbs to get data from the server. And although like nobody actually implements it this way, like the HATOS idea where the response that you get gives you an idea of how to further interact with the service, because there's links to like other endpoints in there. But like that is interesting in that the API is self-describing. And then the other thing is the MIME types, where the servers can say, okay, this is a resource with this particular MIME type, and I'm going to send it over to you, and it's up to you, the client, to be able to figure out like exactly how to interpret this. And so like it's much easier to add a variety of different media and MIME types to the HTTP protocol than it is to be able to do that for RPC, because like that, like you have no idea until you look at the IDL for that particular service.
Yeah. And I think that people do version in an interesting way in REST, in that it's not necessarily a formal part of REST, but in these types of APIs where they just sort of prefix all the endpoints with like V1, V2, and things like that. And you kind of get the versioning for free. And so it's interesting to hear that CORBA struggled with versioning because people just sort of hacked it on top of HTTP, and it seems like it's working decently okay.
Well, yeah. So the other thing is like people don't even agree on like how to do versioning on REST. Like some people like say that it should be in the headers rather than in the URL. But regardless of what it is, at least what happens with versioning is that the entire set of APIs moves forward. Whereas I think in objects it's too granular. So like, do you change like a subset of them, and then if you like need to mix and match between them, that gets to be a little bit of a problem. So then you would have an API in different versions, and you can just use one version or the other. You don't need to straddle between them, especially not at the object level of granularity.
Yeah. And the nice thing about building on top of HTTP is that you get service discovery built in through DNS. And so actually a lot of the need for this object request broker, I imagine, was that you can have object discovery or service discovery going through this thing. But actually now you don't need to.
Well, so with the SOAP and XML sort of thing, I remember I didn't use it a lot, but I remember you could build services that did service discovery for you. So I don't know. I think it just got too complicated, and everybody decided there's no need to do that. We'll do the service discovery out of band through documentation, and so that's the way we're gonna do it. We don't need to like automate service discovery here. Yeah, and so I guess like to wrap up this sort of thing, like CORBA had this vision of the future that the OOP model could be extended to distributed computing. But the future that we ended up with was very different. Like we decided to go with REST, where we send just pure data in mostly a JSON representation over the web. And as the largest distributed system in the world, it's pretty simple, but it works surprisingly. And you have some specialized systems here and there, like either in Erlang or like, within a company, something like Kafka with the message buses. And that's kind of where we ended up. However, RPC lives on today. Like the video did not kill the radio star. And so it exists today in the form of gRPC from Google and Thrift from Facebook, and Java still has RMI. And people still use them at large companies. Do you get it?
Yeah, I use gRPC every day. Actually.
Oh, really? Okay.
Yeah.
So like, are you loving it?
So it works in the case that I use it because the company that I use it at has a giant monolithic code base that everybody codes against. And so it doesn't get rid of the pains of having services run, because once you deploy the code on a service, you can still have drift between your clients and services. Mm-hmm. But the nice thing about having at least all of the code together is that you don't have these concerns where you're coding against an old version of the API, and then it changes from underneath you, but you didn't upgrade the library or whatever. And so I think it requires a certain amount of organizational coordination for it to work technically.
Do you get a sense of why RPC is still being used today? Like when I thought about it, it's mostly, I think if you had a service where you wanted to get rid of the overhead for HTTP and just have like a bidirectional link, that's like one reason. And the other reason is, I think one of the benefits of Thrift as marketed was that it was to connect multi-platform, multi-languages as a bunch of microservices. And so that's the only two reasons I could really think of. But since you use it every day, can you think of other?
Actually, I would say it's mostly historical, in that gRPC was a layer added on top of protocol buffers that were modeled based on some technology, similar technology from Sun, because the people who wrote protocol buffers were inspired by Sun, or they had worked at Sun or something like that. And so it's mostly at this point, I think, just historical incidents. And the thing is that these things have network effects, because once you have some gRPC services, they just kind of proliferate, because you're like, well, I'm talking gRPC anyway, I might as well expose a gRPC endpoint, et cetera, et cetera.
Wait, but I'd always assumed like there would be a good reason to use it, but you're saying that like an accident of history means that they, after all the lessons in the 90s, a couple people said, well, let's just go with this again and see how it turns out. Is that what you're saying?
Yeah, well, gRPC works differently in that, one, it does not have a request broker. And so gRPC basically relies on you to discover the servers that are up using some other information.
Right, some out-of-band thing. Like you just have to know that it's there.
Yeah, so that's one thing. So that's one layer of coupling that is removed. There are some performance benefits as well, in that you don't have to parse HTTP requests, which are text, and then have to treat them as though you don't know what's in them, and you parse them every single time.
Right.
The nice thing about RPC services is that if you have a lot of traffic, as some of these companies do, that are in very predictable patterns, well-known methods that you're calling.
Those are also like binary formats too, right?
Yes.
Or are they optionally binary, or they're all binary?
They are optionally binary, but most of the usage from server to server within your own company is in binary, and then you can expose gRPC services actually to web clients, web browsers, and that would go over sort of a JSON wrapper or something.
Yeah, I can see the initial appeal, especially like if you have a high volume and you need to like connect two services somehow without the overhead of HTTP, like of the request response model. You just want to stream stuff back and forth. It's probably a good thing. But then I would think a lot of the difficulties come after a while, and you have new requirements, so you add a new message type, and then different versions of the same thing, and then that sort of thing. Like, do you know how that's dealt with? I guess protobufs helps with that because like protobufs are backwards compatible, but like it
so
handles that sort of versioning.
Well, you have to be very careful so that you have to use protobufs in a very particular way so that they remain backwards and forwards compatible. And so I think there's some degree of carefulness that needs to happen. And like I said, there's sort of organizational coordination that is only possible at some of these companies just because of the fact that they have a lot of developer tooling, big monolithic code bases.
And a culture of like knowing what the pitfalls are. Because I can see like for some sort of like RPC connection, if you're disciplined and like the domain is constrained enough, you could derive a lot of benefit out of that. But like if you just get developers that just throw stuff on there willy-nilly, like we need this, let's throw it on there. We need that, throw it on there. It can turn into a mess pretty quickly.
Yeah, definitely. And the place where these RPC frameworks break down is actually when companies like mine need to expose endpoints for partners or for customers. They do not use gRPC or Thrift because, again, when you're dealing with somebody who's outside of your sort of domain of control, or you can't force them to follow certain standards, you can't force them to write in a certain way,
right.
Then you start needing all this resilience where you need to handle errors, you need to handle version drift, et cetera, et cetera.
Or like adversarial actors or something like that too, right?
Yeah, adversarial actors as well. Yeah. And actually, there are layers to Thrift and gRPC that add authorization and authentication. And so I think it's not just simple RPC. At this point, it's sort of become this very, very complex affair.
Yeah, because then I guess that also points to an unintended genius of the web in which the messages that get sent over the wire are basically inert data, and that decouples the different systems that need to look at it. And so while there's an inefficiency there because like every client and server that communicates across the web needs to like parse text at each end, but I guess like computers are fast and like most of the delay is over IO anyway, so it's not like these are like CPU constrained sort of things anyways. And so it turned out that this is the way things are. Yeah. So then do you feel like there's any part of CORBA that we can salvage for our future? Like we spent this entire episode pretending like we're in the 90s, like being back in that mindset and projecting forward for the future. Do you think that there's things that we can take from it going forward? Are there like good ideas somewhere in here, or are they just like, we're glad we know it and we're just not going to do that again?
I don't know. I think that it's really, really appealing to deal with objects because in HTTP, it's a very data-forward language or data-forward protocol. There aren't even objects, so to speak.
Mm-hmm.
And so maybe that's the right way to do things, but somehow I think people gravitate towards these object metaphors, and I wonder if you can use, some fancy syntactic transformations, or you have a new type of programming language which, handles side effects better, like side effects over the network better or something, where you can still pretend like you're talking to all these remote objects, but you don't run into fallacies of pretending like they're remote or operating on them as though they're remote.
Wait, so you're suggesting that there's still some way to abstract over remote invocations on objects? Is that the claim?
Maybe. I don't know, right? I think actually I would say this. I retract everything I said. I think that the reason why CORBA is worth knowing is that it is like a siren song, because you look at it and you're like, maybe I should go towards this. And maybe this time I'm going to use a new type of language, a new type of computer science construct, such that it will be better this time, right? And the answer is always no. I think at this point we've tried through CORBA. There have been sort of other RPC implementations like XML RPC and things like this. And generally, this type of model doesn't seem to work. And so I would say that's why it's worth learning about.
Yeah. As a warning to others. And I guess thinking out loud, the reason why it doesn't seem to work is, one, like we said, the pretending like a remote invocation is a local one just doesn't, I guess they're two different beasts. It's like trying to abstract over two things that are actually different. We just happen to give them the same name, and that's why we're trying to abstract over it, I guess. I guess that's the core issue there, right?
Yeah, exactly. And at
because
this point,
your assumption of how time works falls apart in distributed computing. And so I guess that's enough of an abstraction break that it just doesn't work.
Yeah, and it's really hard to get this right. Like even the databases, like I mentioned, where a lot of them are distributed databases by design, they don't get it right. Like there's a great series called Call Me Maybe, or it's like the Jepson series of blog posts where there's this guy who stress tests databases, distributed databases, and a lot of them that are written by professionals, they don't get distributed computing right. And so maybe it's just silly to think that we're going to be able to get it right this time by abstracting over it.
Yeah, we'll put Call Me Maybe in the show notes. Yeah. I guess it's a dead end for a reason, and we find that it should go the other way. I also wonder, like thinking about it, maybe object-oriented programming as it exists in languages outside of Smalltalk, if that's also an eventual dead end as well. Because a lot of times I see functional programming sneaking into mainstream languages, as we've noted in our episode 5, season 1. And there are a lot of books that say things like functional programming in whatever your favorite language is, even though it's not functional at all. Because there's probably some benefits there, and I see these concepts being pulled in there. And so even Go, there's a lot of pressure for them to put in objects. They're just no, we're going to make object-like things that you can treat things as if they were objects in use, but the concept of an object does not exist in Go.
Yeah, and their concurrency model also kind of makes it obvious that you are doing something special and not just doing just normal things. And so yeah, I think that's probably a dead end. Maybe objects, in the way that Java and C++ do them, introduce a lot of problems. Papering over the network introduces problems. Yeah. So actually, I was reading an interesting Hacker News thread with Alan Kay, and
pray tell, what does he say this time?
So he is enthusiastic about the idea that you could have computers discover how to talk to each other without publishing any interfaces. And I think that he is sort of against all of these bastardized versions of OOP, and also sort of against how OOP led us to things like RPC and these tightly coupled interfaces. And so he was very vague and philosophical about it, but he linked to this Wikipedia page for this language, a theoretical language called Linkos. We'll put it in the show notes, which is a way for humans to establish communication with aliens by progressively establishing a set of constructs, first defining the concept of numbers, then the concept of time, onward and onward and onward, until we're able to communicate with an alien species. And in his comment, he said, well, in the same way that Linkos might enable alien communication, maybe computers should be talking to each other like this. And I was like, this is insane. I don't know how this would even work, but the man is a genius, so I don't know.
Well, this actually points me to Brett Victor once again, who is a student of Alan Kay, and one of my favorite talks from Brett is his talk called Future of Programming, which we'll put in the show notes. And he is giving the talk as an IBM employee back in the 70s about the state-of-the-art programming as it was then. And then he's going to project out into the future, which is our today, and he's going to say, surely everything is going to get better. And the reason why it's funny is because it's not. And so one of the things that he says in the talk is okay, we have these declarative programming languages, and surely nowadays what we have is to get two computers to talk over a network, we'll have a person sitting between the computer look up some documentation and then hand code the connection between the two through a quote-unquote API. And so surely this is not the way that they're going to do it in the future, because surely what would happen is that when two computers want to connect to each other, are told to connect to each other, they would self-negotiate a protocol in order to transmit intelligible messages to each other. And so I think this is partly what Alan Kay is trying to get at, is that how is it that two computers that don't start off with any way of connecting to each other build up a communication protocol that then is able to transfer messages to each other on their own without the intervention of humans. And I think Facebook tried this particular experiment with their AI research, and they found that like the two bots ended up inventing their own language and was talking to each other. And when they realized that, they're like, we got to shut this down. And so
yeah, I mean, I think it could work. Maybe, do you feel like AI has to be part of this, or do you think that this is possible even with just general purpose programming languages today?
I want to say it's my guess is that it's probably possible through general programming languages today, but the mathematical framework from which you bootstrap a communication protocol has to be in place. I'm not as familiar with that sort of research, but I imagine something like a category theory. Like you start with like the very basic premise of category theory, in which like I guess there are arrows and then these objects, and from there you can build up a proof. Like the two sides can like try to prove that like the other side understands what I just sent over, and so in that way you build like common understanding of what you're sending over little by little. And so I don't know how long that would actually take in a negotiation process, but maybe like once it's negotiated, the two computers don't have to do it ever again, or there's like some sort of global consensus that for this type of interaction, this is what we agreed on, whether it's intelligible to humans or not. So that's my best guess as a kind of a hand waving thing that I pulled out of my ass. So I don't know.
Yeah, I mean,
and so I guess the reason why that we would use ML is just like, we don't want to deal with whatever, like just have them figure it out. So I don't know.
Right. Yeah, I mean, I think a lot of the time APIs break because they're almost talking the same thing, but they send over the slightly wrong thing, and you put your API key with the slightly wrong header, or they change the format by which you send over some data. And so it would be nice, even if you don't start from first principles of these are how I represent integers and then all the way negotiate to like this business logic.
Right.
Even if you start somewhere in the middle, it would be nice to have some way for the services to the server and the client to negotiate, okay, you're talking this version of the protocol, and I'm going to sort of upgrade you to what I understand, and sort of have these self-healing protocols rather than just having a slight variation in the schema just completely break everything.
Yeah, like how would you, I guess it would just have to, I wonder, so once again, this is more talking out of my butt, but like maybe when one side upgrades their protocol, they're asking the other side to prove that they understand. And so they would have to, they send over a series of challenges, and the other side has to reply back with the correct ones, like the correct answers to show that they understand it. And so when something, like if I am a service and you're connecting to me and I upgrade my service and I migrate, I then send challenges to everybody that were like such as yourself, and then you have to like keep working on the challenges until you get them before you get the rest of the messages. I can see that as being annoying, but it would be one way that like these network APIs would self-heal. That's an interesting concept.
Yeah. Anyway, this is what Alan Kay said was going to be the next big thing. So like if somebody is looking for, some groundbreaking new concepts at the edge of technology, well, there you go.
There you go. Like even in our retro episodes, we're looking to the far future from today. So, but yeah. So I mean, I think like in summary, there are lessons to be learned at dead ends, and I would say CORBA is one of them. But like at the very least, it has led us to an examination of all these other systems that we have today with these nice properties. So yeah, how about you? How do you feel about the retro tech?
Yeah, I mean, I was skeptical going in about why it would be valuable to talk about something that was basically a complete failure. And I think that, computer science as a field doesn't look back often enough and so we're always looking to build the next big thing. And it's worth just looking back and saying, hey, here were these well-intentioned people, presumably well-intentioned.
I would say so. Right? Yeah. Well-intentioned to. Yeah. Anyways, go on.
Yeah. So there are these well-intentioned people, just like us, but that just set back one generation, and this is the path that they went down, and it wasn't successful, and so it's sort of humbling in that way, because it's interesting to think also, like, what is the CORBA of today? Like, what are we sort of bashing our heads at today?
What am I wasting my life with so that I could be grumpy on the core of tomorrow? So
yes, exactly. And I'm sure there are plenty of those. It's sort of humbling to think about the fact that, we are just another instance of the same thing. And hopefully we've learned. It seems like we've learned from those mistakes, but also we're probably making new mistakes, and it's sort of worth thinking critically about that as well.
Yeah, hopefully. Like, maybe on a different episode we can talk about how our field doesn't really communicate these hard-won lessons from one generation to another either. We have no sense of literature, for the lack of a better word. Like, I don't know. Some of these hard-earned lessons, I hope they transfer generationally. So, but yeah.
Yeah. So yeah, I mean, I think it was worth looking back, and it wasn't as depressing as I thought. I think it was actually kind of fun.
Yeah. And so we'll continue to do these retro episodes because, like we said, it's worth taking a look back once in a while. So, but yeah, with that, I am optimistic about the future that we ended up in. I'm glad that we are now programming CORBA and stuff. How about you?
Yeah, I'm thankful I'm not.
Right, but for you, you're doing gRPC, so I don't know how fun.
That's true. But actually now I am optimistic that we're going to have self-healing APIs using Linkos concept. So that's what I'm optimistic about.
Great. All right. So as always, we want you to subscribe, hit that ringtone or whatever, subscribe, like, and all that jazz, and listen to our previous episode before if you like this one. We have more episodes coming in the future for the edge of technology, whether retro or for today, to look at where we're going and where we've been. So this is Will signing off.
This is Sri.
And we'll see you next time. Bye-bye.